Hello, my name is Daniel Houston, and this is my lab for oscillations. Now, for a little bit of background on this lab, we'll look into a spring mass system that oscillates in two dimensions. We will use Tracker to take the observed data for the experiment, and then use VPython to build a computational model of the spring mass system. Now, there are a few assumptions we're going to make throughout this experiment. First of being, the mass of the system will be 0.402 kilograms, and then the time in between frames will be 10.5 frames per second. Additionally, the calibration length of the spring is 0.7 meters. And then from this, we can find the spring stiffness K and the relaxed length L naught. And then the spring stiffness is 6.83 newtons per meters, and the relaxed length of the spring is 0.123 meters. And then these are the equations used to calculate these two values. Now this is going to be the video that we're going to be using today in our lab, and as you can see, there's a spring moving in two dimensions. And this data will be recorded using Tracker. We are now able to build our computational model, and this is done using the previously calculated values, as well as Newton's second law and the energy principle. And this is done in VPython. And here is the code running. We will now take a look at some specific things in the code, such as where the kinetic energy and then the potential energies come from. The kinetic energy is 1/2 times the mass times the velocity squared. The gravitational potential energy is the mass times the gravity times the position in the y direction. And the spring potential energy is 1/2 times the stiffness times the value S squared. And then the energy principle ties the kinetic energy with the potential energies. The energy principle is satisfied because the total energy equals the kinetic and the potential energies, therefore no energy is lost. And this is seen in the graph as the spring potential energy moves in the negative direction, the potential energy of gravity moves in the positive direction, and both of these cancel out to equal 0, as well as with the change in kinetic energy. And then using the tracker data, we can see the oscillations for both the x and the x being 1.679 seconds, while the y being 1.524 seconds. And then these average oscillations values are very close together. However, the y value is slightly smaller than the x value. Thank you for listening to my lab.